Hello and welcome to another video on the mathematical fundamentals. So in today's video, I'm going to make a quick recap of what I have learned from the previous topic, which is generalize, as a way to understand the value proposition that I'm getting from this course or that I'm getting from the previous stage, as a way to understand how can I apply that. And when it comes to solve someone else's problems, especially from my client problems, I can do that in an efficient and effective and fast way. And also apply all of those concepts and see how can I solve my own problems. That's the whole point of today's video. Make a quick recap of the generalized topic, okay? And then move on to the next one, which is rewrite, rethink, and redraw. And as a way also to not only improve my communication skills in English, but also with the Spanish as well, and the mathematical jargon, the mathematical language. So the previous topic, we look at two things. Two content. So first is the value proposition from this mathematical fundamentals course from Brilliant.org. And Brilliant.org is it was a startup idea founded in 2012 by this is the name here, by Sue King, right? So he present the idea and then attract some of these venture capitalists like Chatmat Palihapitiya, okay? Chamat Palihapitiya, I think I pronounced that right. Chamat Palihapitiya, okay? He was an early senior executive at Facebook from 2007 to 2011, only 4 years. In 4 years, he was able to capitalize enough to then start a fund called Social Capital. Okay, so where he invests in companies like Slack and Jammer. Okay, so with this huge introduction about Brilliant.org, okay, and who is the co-founder and the CEO, Sue King, and once he present this idea, some venture capitalists, in this case, Chamat Palihapitiya, exactly, Chamat Palihapitiya, he say, hey, yes, I'm going to invest in your idea. I understand that, and also I want you to capitalize from this. Okay, so Chamat Palihapitiya, after all, he is a senior executive work at Facebook. So he was a senior executive at Facebook from 2007 to 2011, and then he found or he started a fund in 2012 called right now Social Capital. Okay, so he invests in companies like Jammer and Slack. All right, so the whole point of the generalize is to now understand the value proposition of, first, as I mentioned, the value proposition of this course, the mathematical fundamentals, okay, because it will provide us toolkits that are necessary, relevant, especially when we want to tackle some, or we wanna tackle daily problems. So mastering algebra and understand what algebra is. So mastering algebra, this toolkit, the logic as well as the number theory, okay, is part of the fundamentals of this. Again, this is much like when you have skill set from like your LOL, okay, League of Legends character, that you adding is skill set spells to that. So much like human in the real world is quite abstract, but the thing is that it can solve you it can help you to solve real life problems. So in any case, so the value proposition of these mathematical fundamentals is that brilliant Brilliant will provide you essential tools to master things like algebra, logic, and number theory. Okay? So to understand this, first we need to look at the generalize and also understand what is the value proposition of mathematicians and where the mathematician word comes from the Greek word mathema, which stands for which it means one's what gets to learn, what one gets to learn. And I love this because it's something that you don't know, but you are invited to learn. So what one gets to know. And the mathematic or the mathematicos was the name given to those people that get to know things. Okay. Uh, so then I look at how this is the value proposition of the mathematics. Okay. So by generalize from single real life examples, so by identify specific problems and then generalize that using algebra, particularly here we're going to look at the mathematic with the arithmetic, okay, the arithmetic tech, which is the art of counting. It comes from the Greek word. So this art of counting, we're going to see an example of how this generalization or how the mathematician think. Okay, so by looking at this specific pattern, okay, which is with numbers, something that they mention here. All right. Uh, so yeah, so the value proposition here of the mathematical fundamental from Brilliant.org is learn to think like a mathematician. Okay, like a League of Legends role in LOL or Fortnite. Okay, you are is this role where you can add some spell, you can learn some spell. So use basic spells to solve real life problems like counting, arithmetic, and generalizations, algebra. And also we have is the number theory, logic and number theory. So for example, logic and number theory. Okay? But again, for this course, this is the value proposition of the mathematical fundamentals, right? From Brilliant.org. So they provide you ways of how you can think like a mathematician, and a mathematician is just someone that the word mathema means what one gets to know. So it's someone that actually put a practice that to solve real life problems. Okay, specifically at level one or basic level is the art of counting. Okay, arithmetic, generalization, algebra, in using logic and number theory. Pretty basic stuff here. Pretty basic stuff. Cool. So So this particular course, okay, or the lesson here in the generalize is to look how a particular example, look a pattern from, yeah, look a particular example, specifically looking at patterns in the arithmetic, okay, the operations on numbers, addition, subtractions, multiplications, and division, uh, and turn those patterns into general principles that we can represent using algebra. So with that, okay, with this specific use case, with this specific example, all right, uh, and see here we're gonna see how we can learn arithmetic through visualizations, because it will help us to understand why and how the algebraic techniques works. And this is something that you're gonna learn from a course. What is the techniques and what is the strategy that that can use from you and see if they are applied to my daily life? Okay. So just to recap here, so far I have talked about is the mathematical fundamentals from brilliant.org. The reason of looking at this is to actually wants to have a solid foundation here, as well as update my knowledge in English, which is very, 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 very important. Okay, and because I already have that base on Spanish, but in English is something that I need to improve. Okay, that's the reason why I'm looking here, because I also want to not only be able to understand mathematical fundamentals, but also how to solve problems, specifically using software engineering skill set. So that structure, an algorithm, and how beautiful it is and powerful. You know. So with that, okay. So that's the whole. That's my reason why I'm looking here. Okay. I'm looking at the mathematical. I'm looking at the Jesus. And looking at the mathematical fundamentals, because not only want to learn that, but also see how can solve real life problems for myself and for clients using software engineering toolkits like data structure and algorithm, specifically in JavaScript for building web applications, for the front end and for APIs. So that's the entire reason why I'm looking here, so I can get value from these people. In this case, I can exchange uh, my knowledge for money. Okay, so I can then start to understand more and more. So I can then actually uh, be someone like Chamat Palihapatiya. So create a fund where I can start, where I can fund, or I can see other fundings. Okay, and also as a way to invest, because this is also where the value it is. All right. So yes. So we look at the who found that. Okay. Who is the co-founder? Is this co-founder how he present that to a venture capitalist like Chamat Palihapatiya? Where this venture capitalists come from? What is the background of this venture capitalist? Which is from a senior executive from 2007 2011 at Facebook. Okay, and later on he created a fund called Social Capital. So this is a pattern here as well. So people that work on the industry, specifically on the tech industry, and then how by working couple years in that industry, then he get out of there with some money. He wants to try to invest or create a fund to invest in other companies or other startup and ideas. All right. So that's the pattern here. There will be a lot of company, okay, that they are not going to be profitable, okay, uh, and there will be few ones that actually are profitable. So, anyways, and well, in the value proposition here, the course is to think like a mathematician. Think like a mathematician, uh, so much like this, like a character in League of Legends or Fortnite. Okay, so you will be able to have spells to solve real life problems, specifically using arithmetic or the art of counting, the algebra, how you can generalize based on specific patterns, uh, using also number theory to describe the numbers, as well as the relationship and logic. What is the series of steps to do something? What is the logic behind that? So we're gonna see all of this. First is by looking at an example to identify is a pattern in the arithmetic. So by looking at this pattern in arithmetic, there's operations on numbers, addition, subtraction, multiplication, and division. And from those patterns, be able to generalize or to generate general principles using algebra. And this is the core of algebra. It's because based on specific patterns, things that are repeated, so you don't need to actually calculate that. We have is this. We need to understand where is the context where we can apply this. That's the whole idea of this. That makes sense. That makes a lot of sense. So the example here that I look is, what is the sum of all of the first odd numbers? Okay, and using these visualizations to actually look up for patterns, because at the end of the day, the whole point of using mathematics is to demonstrate those patterns. It's like how and why can we demonstrate those patterns? So the pattern that I demonstrate here is, what is the sum of all of the n odd numbers? So instead of calculating this, so for example, if I tell you what is the sum of all of the first 7 numbers, okay, so instead of sum all of that, you now abstract this formula or this algebraic expression, which is n power 2. And I also look at how can we demonstrate using visualizations that concept. Okay, so again, the sum of the first odd, the sum of the first 7 odd numbers is 7 power 2. 7 by 7 is 49. Then period, 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 period. Just like that, just like that. And you may wonder, even though instead of even this operation of 7 by 7, because it's adding 7 times 7 to itself, so 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus blah, 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 plus 7. So you just have these multiplications that are somewhat useful for you, so you don't have to calculate. So by you memorizing that, especially when you have to go out in the wild, for example, you want to buy some avocados or strawberries or several pizzas, you know how what will be. For example, you wanna buy 3 pizzas and 6 packs. Okay, 3 pizzas and 2 6 packs. Okay, 3 pizzas at 3.999. That was very cheap pizza. You shouldn't buy that anyway. 3 pizzas at 3.999 and 2 6 pack at 5.99. So by using these tables, okay, so we help us to, so we reduce the amount of time that we need to think of that. That's all. So we can now do something else much more faster and easy. All right. So this was the demonstration of why n power 2 describe this particular pattern for this use case, for this problem, okay? Which is, what is the sum of all of the n? What is the sum of all of the first n of numbers starting from 0 or starting from 1? Okay. All right. So this was very, very beautiful here. So anytime you see this kind of pattern, it's like, when can I? Is there a use? So anytime you see a problem in mathematics like this, again in arithmetic like this, it's like, when can I use? Okay. When can I use this? Is there any unusual pattern? So can I see some unusual pattern here? Will this pattern hold for other similar problems? Okay, and how can I prove it? And this is the value proposition of the mathematics. Again, the value proposition of the mathematics is that the practice of trying to generalize a lesson or to generalize a problem uh, you learn is the core of mathematics. Math is all about understanding why patterns arise. Very, 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 very important. So according to brilliant.org, okay, math is all about to understand why patterns arise. So the practice of trying to generalize a lesson, okay, and this is it. Again, remember the mathematics or the mathema, which is the one what one gets to know, okay, is why patterns arise. What these things that I'm knowing exist. Okay? Alright. That was very, very, very interesting. Yeah, that was very, very interesting. Yep. It was very, very, very interesting. Mm-hmm. Alright. Okay. So the value proposition of mathematics, exactly. Mathematics from brilliant.org. Mathematics is all about understanding why this pattern emerged. Math is understanding. Math is all about understanding. So mathematic value proposition. Math is all about understanding why patterns arise. This is it with mathematics. So mathematics is all about understanding why patterns arise. Because mathema, after all, is the description or the definition of mathema, or the meaning of mathema is what ones get to know, according to Wikipedia, right? So what ones gets to know. Please correct me, some mathematician that actually understand that, or that have dedicated his life or her life to that. But yeah, I would like to. I would also like to understand. I would also like to talk about this to him. Yeah, I would also love to talk about this with him. So math is all about understanding why patterns arise. Okay, that's right. Yep, simple man, simple, pretty straightforward, pretty straightforward, pretty, pretty, pretty straightforward. Mm-hmm. Okay, the thing is this. Okay, there you got it. All right. Okay, okay. Cool. Hmm. So when someone asks me, hey, where all of this knowledge come from? I can tell them, hey, this come from Brilliant.org. Hey, this online platform for profit and co-founded by co-founded by Soo Kim, co-founded by Soo Kim, and founded so co-founded by Soo Kim, and so he presented that idea to other venture capitalists, and Chamat Palihapitiya came here and said, yes, okay, let's go. Uh, so he come from Facebook. He worked he worked as a senior executive from 2007 to 2011. So yeah, very, very, very interesting. Very, very, very interesting. Very, 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 very interesting. Very, very, very interesting. Very, 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 very interesting. But then you. Mm-hmm. All right. So what's next? What's next? Here we are. Rewrite and rethink and redraw. Explore fractal patterns and compound interest in the mathematical of fraction. Okay. Of course. Of course, of course, of course, of course. All right. So this is like this. And this belongs to this. Okay. So right after that we got is this. Rewrite, rethink, and redraw. Rewrite, rethink, and redraw. All right. Exactly. Explore fractal patterns in compound interest. Explore fractal patterns in compound interest in the mathematics of fraction. In the mathematics of fractions. Holy F. Exactly. Explore fractal patterns and compound interest in the mathematics of fractions. A good example of the compound interest in mathematical of fractions is, for example, if you dedicate to the gym an hour every day, you eventually, of course, you need to integrate that with other portion in your life, okay, like nutrition, socialize, um, and also to earn money and that kind of thing. If you now summarize all of these compound interests, okay, using fraction, you will get somewhat closer to the outcomes you want. A little bit abstract. Let's going to summarize this. It's going to be more tangible. So, if you dedicate, for example, let's going to focus this in two things, right? Two things here is nutrition and nutrition and fitness. So if you dedicate 1 hour every day to that, to the fitness, and then you schedule your meals, okay, to actually achieve the same goal, which is the end goal of this is um, how do you put it? The same goal is to be fit and healthy, okay. So if you look at now these two portions using mathematical fractions, this is the two things that you have to do to actually get that outcome. Again, this is an oversimplification because there is a lot of factors, by the way, but looking at the compound interest here in the mathematics of fraction is something that I'm witness. Look at me. Look at me. Holy moly. Mm-hmm. Mm-hmm. All right. All right. Okay. So this course is all about learning to see math in a new way. By visualizing fraction less than 1, we'll learn about beautiful mathematical pattern called fractals. While fractions greater than 1 will reveal the exponential growth of compound interest. Eventually, we'll get to the elephant in the room. Okay. Okay. So this course is all about, yeah, this code is all about learning to see math in a new way, learning to see math in a new way. Okay. By visualizing fraction less than 1, so by visualizing visualizing fraction, Jesus, by visualizing, oh my god, by visualizing fractions less than 1, okay, we'll learn about beautiful mathematical pattern called fractals. We'll learn, yeah, we'll learn about beautiful beautiful mathematical patterns called fractals. While fractions greater than 1, while fractions greater than 1 will reveal the exponential growth of compound interest. Will reveal the exponential growth of compound interest. Two things here. Fraction less than 1, so fractions less than 1, we'll see the beautiful pattern called fractals. And fractions greater than 1 will reveal the exponential growth of compound interest. Eventually, we'll get to the elephant in the room. Exactly. Eventually, we'll get to the elephant in the room. Suppose we start with this triangle and then we cut up a piece. Here we are with the 3/4 from Zelda, by the way. You know, what is the area of the new shape compared to the first? So you got is this, okay? So the area of the new shape compared to the first. So if we're assuming that each triangle is the same, so the area of the new shape will be is 3/4. That's right. Which of the two number is smaller? Interesting. Which of the two numbers is smaller? 3/4, which 3/4 is 0.75, I recall that way. Okay. 3 divided by 4, exactly 0.75. So if I double that, if I say 3 divided 4, or 3/4, so how you, yeah, it's like how you pronounce, so how you pronounce fractions, how you pronounce fractions like this in English. Uh, 3/4 or 3/4. Number 3/4. 3/4. Exactly. 3/4 using cardinal. Okay. Yeah, but how to pronounce fractions in general? One half, 3/4, 5/8, 5/8, 3/4. This is a general guideline, and there can be variation in pronunciation based on regional accent or personal preference. Okay, 5/8, 3/4, one half, one half, 3/4, 5/8, and even pronunciate fraction in English is something that I know quite familiar. In Spanish, I know how to do, and I know how to say that. 5/8, 3/4, un medio. Okay, I know how to pronounce that in Spanish. 3/4, 5/8, fifth eighth, or 5/8, 3/4, 1/2. Interesting. So if you now, for example, multiply these two numbers, 0.75 is interesting. 0.75 per 0.75. So multiplying numbers less than zero will give you even uh, is uh, less than that. We didn't need to calculate anything to answer this question. Instead, we just need to recognize that 3/4 per 3/4 is the same thing as taking 3/4, which result in a smaller number. Okay? Again, we all start with this. So we all start with the triangle, okay? And then we take off a piece from this, and we ask ourselves, again, if the piece that we take is the same, great, great. So which of these has a shade area 3/4 or 3/4 of the full triangle? So remember, this of the full triangle, because we remove a somewhat same element here, okay? Because I remove that element here, uh, and then I multiply that, meaning that to multiply this, I say, well, uh, this multiplication here, these multiplications here, which of these has a shade area? 3/4 and 3/4 of the full triangle. Which of these has a shade area? 3/4 of the 3/4 full. Interesting. So we talk about this, right? So this is a smaller. So which of this has a shade area? Per 3/4. Again, this represents one element, and if we multiply by itself, it's only 2. Interesting. Which of these has shade area? We didn't need to calculate anything to answer this question. Yes, we didn't need to calculate anything to answer this question. Because if you multiply this by itself, you will get is a lesser value. This is one of the property here with arithmetic, even with adding numbers. hmm Because it's adding, but here we're multiplying. Mm, exactly. Uh-huh. Okay. So it means that is exactly is so multiplication. Jesus. Okay, got it. So multiplication here is this 75. Okay, but you're gonna add that 75 times. It's not a complete number. So you're gonna add that 75 times. You're gonna add that 75 times. Interesting. Again, this is with, exactly. Again, this is for natural numbers. Okay, but when it comes to fraction, okay, the educated monkey, a thing toy dated 1980, used a multiplication calculator. An educated monkey. Historical algorithm. Oh, okay, explains Egyptians, Babylons, Chinese, modern methods. Okay, but again, this is interesting. Exactly, this is interesting for natural numbers, multiplication with set theories. This is interesting for natural numbers. You know what it means? This is interesting for natural numbers. You're talking about complex product of two fraction. The product of two fractions. Because what we're talking about is the integers. And integers makes sense. But with fraction, two fractions can be multiplied by multiplying the numerators and denominators. So it means that the numerators 3 plus 3, and then the numerator 4 plus 4, which is 8, and then you divide that. 6 divide 8. I mean, they need to be multiply exactly. 3 per 3 is 9, sorry. 9 and 16. Exactly. This is the way how do you divide this. Okay. Oh my god. Fraction division. Okay. Which of these has a shade area 3, 4, and 3, 4? Okay. Of the full triangle. Meaning, so fraction multiplication is this 4 by 4, which is 16, and then you have 3 by 3, which is 9. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements, okay, of the 16 portions. So the 8 seems to be the question, seems to be the full triangle, right? The animation show what happened when you multiply 3 divide 4. So you're removing is that element, exactly. But again, this is some elements that are the same, okay? So the animation show what happened when you multiply it by 3 times. And it add this triangle here, and then it add a triangle in each one of those areas. Here, here, and here. Exactly. Oh my god. What will happen if we multiply the area 3, 1, 3, 4 one more time? You will get this even, okay, even smaller fraction of shaded triangle. Exactly. This is the shape with an area 3, 4, 3 of the original. So we could keep going multiplying 3, 4 every time. So this is the first time, and then you multiply these fractions. Here you're gonna get is so you are removing is each one of those elements, okay? Because here, how you can represent this in this triangle is by removing an element here. Remember, the division is that you're split something in the same part. So is this, that's right, and then you do this, okay? And if you do that again, you will do that for each triangle. And if you do that again, you're gonna do per each triangle here. And if you do that again, you do that per each triangle. God damn. This is the so this is the entire triangle. Okay. Once you do this, great. You multiply that by a fraction. To actually represent is this fraction. And then if you multiply that fraction again, which is 2 power 2, power 3, power 4, power 5, you get the idea. As we keep going with the process, what happened to the total area? The total area gets smaller and smaller. No. The total area, it stays the same. The total area stays the same. What we're talking about is the total area. No, the area is getting smaller because pieces are being removed each time. But you have to be very specific, my friend. As we keep going with the process, what happens to the shaded area? Not the total area, the shaded area. The shaded area, yes, gets smaller and smaller. But the total area remains the same. So if we repeat the step an infinite number of times, then all of the area will be removed, leaving only the outline of an infinite number of triangles. This shape called Sierpinski triangle and is well-known example of a fractal. A fractal is a pattern where similar patterns appear at all smaller scale as you zoom in. What this means is that you find an infinite number of copies of the Sierpinski triangle nested inside itself. Sierpinski triangle, Russian. It must be Russian. Or Polish. Somewhat close. Interesting. So this is called Sierpinski triangle. Sierpinski. Holy fudge. Sierpinski triangle. Sierpinski triangle. Exactly. Sierpinski triangle. All right. Sierpinski triangle. Sierpinski triangle, which is a fractal representation of that. What this means is that you will find an infinite number of copies of the Sierpinski triangle nested inside of this. So the Sierpinski triangle, what it means is that you will find an infinite amount of triangles nested inside of itself. Copy after copy after copy after copy after copy after copy. Again, okay. Fractals are fascinating mathematical objects. As we discover this one by just visualizing the simple act of multiplication 3/4. As you study more math, you will notice that that beautiful pattern and insight weight behind every corner. Next, we're going to see a different side of fraction, this time by considering fractions greater than 1. Okay. Interesting. So, that'll be all for this video. Take care. Bye-bye.